David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, exponential functions and transformations. This one's kind of complicated, so I want to start with a basic introduction of what we're going to do. Here is a standard exponential function, variable in the exponent. Now, we can multiply this base times the exponent by some k, and that's going to give us a transformation. We can also add some k out to the end. That gives us a different kind of a transformation. We can also add or subtract some k from our exponent. That also gives us a different translation or transformation. In fact, we can also divide or multiply the exponent by some k. There's a division. We could also do it as kx. So here's the thing you need to keep track of. K is the transformation factor. So we're going to use that same letter every time. But k is going to happen in a lot of different places in our function. I'm going to put nice things on the board for your notes. If you follow along, I'm sure you can get it, but just keep track. Okay, let's do some translations. Check this out. The equations look different depending on the translation that you're doing. This one is for the vertical translation. This one is for the horizontal translation. Notice, to change the function vertically, we manipulate the k that's outside of the exponential part of our expression. But to slide it right or left, we manipulate the exponent part of our function. Okay? So let's take a peek at how that works. If we're going to slide it up or down, we just add or subtract this value to the expression there. And so if k is bigger than 0, makes sense, it goes up. If k is less than 0, it goes down. This is the whole function shifting on the graph. And in our translation notation, that's just 0k. Now to slide it right or left, we just add or subtract the k from the exponent itself up here. And so if k is bigger than 0, we slide to the right. And if k is less than 0, we slide to the left. That also makes good intuitive sense. Let's do that in Desmos. Okay, here we are in Desmos. And I have my y equals 2 to the x graph already posted in here for reference. Let's do a vertical translation. So we're going to use y equals 2 caret x plus 2. And notice how that just shifted our graph upwards. Now we have a horizontal asymptote at the line y equals 2. Let's try another one. Let's try going down. Y equals 2 caret x minus 3. And check it out. Now we shifted down 3. Same graph, same shape. Don't let the fact that they're getting closer together confuse you. These are the same graphs. All right. So let's take a look. I'm going to remove these last two, and we're going to do the other translation. Y equals 2 caret. Now to do this in Desmos, you have to start with parentheses. Otherwise, it's just going to get confused on you. So minus, you're going to do minus 2. And check it out. Now that graph shifted to the right. Now remember, this is confusing. There's a lot of places in equations and formulas where you have to reverse the sign. Okay, so what this is doing is that whatever exponent value you put in for x, it's subtracting 2 from that. So before you raise it to a power, you're reducing that power. So what's going to happen is it's going to delay the increase. It's going to delay the increase in y. So here's what's happening is this function, same shape, but it's just waiting longer until it gets up and scoots up towards the top. Let's try one the other way. Y equals 2 caret x. Whoops. No, I didn't do that right. 2 caret parentheses x plus 3. Now check that one out. Now that I'm adding to my exponent before I apply it to the base, it's increasing faster. And indeed, this green graph has shifted quicker and further over to the left. Okay, now let's do some reflexons. This one is the easiest of the translations that we're going to talk about. reflections are pretty straightforward. If you want to reflect across the y-axis, you just put a negative in front of the a. Or a better way to say it is you change the sign of whatever's in front of your base on your exponent. So what this does is reflect it across the y-axis. Here's our notations from our reflections section. Okay, if you want to reflect it across the x-axis, you put the negative in front of the exponent, or change the sign of the exponent. So this is a reflection across the x-axis, m sub x. Let's do that in Desmos. Okay, here we are in Desmos again, and I have my basic y equals 2 to the x doubling function up for reference, and I'm going to reflect it across the x-axis. But before I do that, I want you to think, what do I do to my function to get that to happen? If you thought y equals minus 2 to the x would do it, you're right. There we go. We got a nice sweet reflection across our x-axis with the black line there. Let's scoot this up a little bit. Okay, let's do across the y-axis, y equals 2 caret negative x. Boom. Let's get this one out of the way. So you can see that this second brown line, that's weird. They gave us two of the same color. Here's our y equals 2 to the x. Here's our y equals 2 to the minus x. So it changed it from an increasing to a decreasing function simply by reflecting it across the y-axis. Okay, let's do some dilations. By far the most complicated of our exponential transformations. So two ways. We can dilate vertically, that's a stretching up or stretching down with respect to the x-axis, or horizontal, which is a stretching right or stretching left, which is respect to the y-axis. So with a vertical dilation, that's caused by having your k be outside the exponential part of the function. So this is the coefficient, and it gets multiplied by the exponential part. For the horizontal dilation, the k winds up in the exponent. It's divided into the exponent itself, and that controls the stretching left and right. So let's take a look at our parameters. When k is bigger than 1 for our vertical dilation, this thing is going to move away from the x-axis. So it's going to move further up, or it's going to stretch further down. When k is between 0 and 1, it moves towards the x-axis. So this is like a reduction. This is like an enlargement. This is like a reduction. In the horizontal realm, when our k, remember it's underneath the x in the exponent part, when k is bigger than 1, it's going to move away from the y-axis. So it's going to stretch out. When k is between 0 and 1, it's going to move towards the y-axis. So it's going to get reeled in. So again, enlargement and reduction, and our scale factor is k. So there you go. Let's do that in Desmos. Okay, so here we are in Desmos with our base function, our y equals 2 to the x. Now we're going to do some dilations. So let's take a look at a vertical dilation first. I want to stretch it away. I want to do a vertical enlargement. So take a minute, think about what I might need to do to my function to accomplish that. Okay, if you remembered that this is accomplished by using the coefficient, you would probably have gotten that right. So we'll do 4 times 2 to the x, and presto. Notice how we are stretching it further away from the x-axis. Here's our x-axis, so it's stretching further away. It's rising faster. It's getting away from that x-axis more quickly. Okay, so let's try a reduction in the vertical direction. Y equals, let's just do 1/4. I typed that in so that it showed up as a fraction, 2 caret x. And check it out. Now my purplish line is the graph has come much closer to the x-axis. It's rising more slowly. Now let me show you something that might bug you with Desmos. I noticed this recently. I'm sure maybe it's an entry error, but I haven't figured it out. So if I were to use a decimal instead of a quarter, y equals 0.25 space 2 caret x, I get a reflection. Okay, so this one is quite different than entering it as a fraction. So I recommend that you do these as fractions. So let's do some horizontal translations. Let me put one in there for you. Y equals 2 caret parentheses
Now I want to have, let's just do a scale factor of bigger than 1. So we're going to go scale factor bigger than 1. Let's try x over 5. There we go. So check that out. That moved it away from the y-axis. Notice here's our base function here, the red, and this one is stretching it out. So this is an enlargement with a scale factor of 5. Okay, so now let's do a reduction, which is going to pull the graph closer to the y-axis. Take a minute, think about how you might do that. Y equals, so instead of dividing x by 5, I want to divide it by 1/5. So this is a little interesting. Divided by 1/5 is the same as multiplying by 5. So I'm just going to go ahead and put in 5x there and check it out. Now my new blue graph is definitely pulling in towards the y-axis. It's moving closer, which makes this a reduction. So a word on these reductions and enlargements in both directions. It's not as visually obvious as, say, reducing or enlarging a square or a shape or a point. It's just not as obvious. So just, you might want to make some notes to yourself to make sure that you remember that, okay?
Okay, let's put this all together in one equation and see if you can tease out all the transformations that are in there. Here's my equation. What I'd like to do is pause the video, see if you can figure out what the translation, what the reflection, and what the dilations are. Okay, let's see how you did. Our 5 out here is our y direction. That's the horizontal part of the slide. So I'm going to use my notation. That's the horizontal part right there. And now the one in the exponent is the vertical part. So we've got a -2. That means we change the sign and we put that there. So that's our translation. 2 in the x, 5 in the y. So it's moving it in a positive direction out into the first quadrant. Take a look at the reflection. So when the negative shows up here in the exponent, we're reflecting across the y-axis. So it's my. That's our reflection. Now our dilation happens right here. That's the 4. And what are we doing? Is that a vertical or a horizontal? Pause the video and think about that. If you got vertical, you're right. This is away from x-axis. And the k is 4. So the scale factor on that one is 4. Let's take a look at this in Desmos.
Okay, here we are in Desmos, and we're back to our base function, our y equals 2 to the x, our doubling function. And let's go ahead and put in this new function that has like all the things going on. So that's y equals 4. And I'm just putting a space in there, and that allows it to be multiplied by the exponential part of our function. So we're using 2. My caret key gets me up there. I've got my negative parentheses, x minus 2 parentheses. Now the arrow key to the right is going to get me down so I can type in my +5. And check it out. So the purple graph is our transformed function. Let's go over what happened here. We had a we had a slide. We went 2 to the right and 5 up, and that makes sense with where my location is there. We had a reflection. So we reflected across the y-axis. That's the vertical axis. So instead of an increasing function, we now have a decreasing function, okay? Okay, so let's look at the dilation. Our scale factor is 4, so we know that we have an enlargement. It's going to move away from the x-axis more quickly, and indeed, that's what we do. Check it out. Here, it's rising much more quickly and steeply. So there you go. A last statement about Desmos. Use this tool. It's powerful. It'll let you compare graphs quickly and easily. Just remember that you're going to need to be able to do an occasional graph by hand. That skill is still a very good skill for you to have. So I just want to thank you for paying attention to this, I think, rather long video. There's a lot going on. You want to be sure you practice all of the material in here and ask questions in class if you have them.
Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below And if you'd like to help me grow my YouTube channel, please click subscribe.